go. I have like 50 messages on my computer screen to do that. Thank you, Andres. But for those of you who don't know, we do record all of the webinars that we do. We have algebra, geometry, and advanced algebra webinars, and then we also have Sketchpad webinars every month. Every Monday, Tuesday, there's some kind of webinar going on. We do record all of the webinars, and for the Sketchpad ones, we also provide you with any of the documents that are used during the webinar. We provide those as well. So you can find all of our recordings for our previous webinars on our website at keypress.com/webinars. So if you've missed any of the previous Sketchpad webinars, we've had one on elementary, we've had it on middle school, we've had it on calculus, lots of different topics, and we will continue to have them. So the recordings are always there if you miss one. And go to our site and you can see them, and you can also see the upcoming ones that are coming up in the next month. We are trying to do these every month as much as possible, except for December. We're all taking a break. All right, we are going to start in about a minute. So Andres, in a minute, I'm going to turn over control to you. Everyone who's just joined us, we're just doing sound checks and visual checks. So if you are having any problems at all, please let us know by typing in the question panel. And again, if you can't see your question panel, your control panel might be minimized. So maximize it by hitting the red arrow at the top right hand of your screen. And you may have to go to view and unclick the auto hide control panel option, which sometimes happens. All right, I'm not seeing, I'm just looking at the quick questions. It doesn't look like anyone is having any major issues. Again, those of you just joining, if you can't see the scrolling screen, which currently is saying check out previous and future key webinars, it might be because your second window is behind the first window. So minimize the window you're seeing and you should be able to see the presentation. That's usually the problem that we have. All right, Andres, I think maybe we should go ahead and get started. So I am going to relinquish control all the way over to you. So is your screen ready, Andres?
It is.
All right, here we go. You are now the keeper of the webinar. Go.
Hello, everybody. My name is Andres, and I was a public school teacher for 13 years before I started working here at Key Curriculum Press. I've been here for about 6 years. And I had the fortune of using Sketchpad as a teacher in the classroom. And the things that I'm going to be presenting today are the kinds of activities that I used to do with students in the classroom all the time.
Andres?
Yes?
You need to remember to hit show your screen because we're not seeing your stuff.
Okay.
It's up at the top. There we go. Fabulous.
Sorry about that. So this is a brief overview of what I'm going to be talking about over the next hour. We specifically wanted to make a webinar that was geared towards people who have not used Sketchpad before or who have very little experience with Sketchpad. So I will be showing some fundamental features of Sketchpad. We also looked at the information for those of you that are participating ahead of time, and it looked about half of you were using Sketchpad 5 and half of you are using Sketchpad 4. This presentation is going to be all in Sketchpad 5, and I'll take a little bit of time to highlight some of the features that are new to Sketchpad 5 for those of you that are currently using Sketchpad 4. All right, before we get started, I wanted to ask a quick poll question. The last couple of weeks, I've been working quite a bit on the Common Core, and so I'm going to ask a question, and you'll all be able to reply to this question on your screen in just a second. And if I remember from yesterday, those of you with Macs, you're not going to see the whole question. It gets cut off, so I'll read it out loud. So here's the question. And the full question is, in the Common Core state standards, which grade is classified two-dimensional figures in a hierarchy based on properties? So in the Common Core state standards, which grade level has the standard classify two-dimensional figures in a hierarchy based on properties? Okay, and I see about almost half of you have voted. I'll give you another 10 or 15 seconds. And then I'll share the results. Got about 3/4 of you now. So another 5 seconds. Okay, great. We're up over 80%. All right, just close the poll, and here are the results. Looks like a pretty, about 1/4 of you 5th grade, 1/4 of you 6th grade, a little bit less than that 7th, and then a smaller number 8th grade in high school geometry. All right, I will come back to this question later in this webinar. I'll tell you what the answer is then. But first we're going to start with constructions. So for those of you that are not familiar with Sketchpad, Sketchpad has a set of tools over here on the left, and we're going to start with a circle. You might want to know why I started with a circle if I'm trying to make a triangle, but the circle has a special property that all of the radii of a circle are congruent. So I've just constructed one radius of the circle, and now I'm going to construct a second radius. And you'll notice that when I get to the second point, the circle gets highlighted. I'm going to go ahead and choose my arrow tool, and now I'm going to drag the second point, and you'll see that it's constructed to be on the circle. I can't pull it off the circle. This point's a little bit different than the other one because this point was the one I used to create the circle in the first place. So when I drag it, it changes the size of the circle. But no matter what, both of these radii have the same length. Okay, so for those of you that are familiar with Sketchpad 4, you'll see some new tools over here. There's a polygon tool that allows me to construct a polygon with its edges, or just the edges of the polygon. And so I'm going to go ahead and use this polygon tool with edges to finish off my triangle. I'm going to click on the first point, the second point, the third point, and then you'll see I could keep on going, but if I go back to the first point again and click there, it finishes the polygon. So at this point, I have a triangle, and you'll notice that no matter how big or how small I make it, or how much I change it, it always remains an isosceles triangle. A couple more features in Sketchpad 5. This tool here is called the marker tool. And the marker tool allows me to make a number of different kinds of marks. I can just draw freehand if I wanted to, so I could just annotate if I wanted to, just by drawing. But when I use the marker tool on a segment, it creates, in this case, well, last time I used it, I was making parallel markers, so I'm going to right-click on this and change it to just a crossbar, because right now I want to indicate congruence. And if I keep clicking it, I can change the number of hash marks. So right now I'm just going to use one hash mark, and then I'm going to do the same thing over here. So now I can indicate that these two sides have the same length. Depending on when you're doing this and how old your students are and what their background knowledge is, you know, there's a lot of things you could do at this point. You might want to verify that these things are in fact the same length. So I'm going to go ahead and select both of these segments and measure them. And as I change the size of the circle, you'll notice that both of the measurements update and that they're always the same. Karen, I can hear your typing.
Sorry.
And then I'm going to, last thing that the marker tool can do is I can construct angle markers. So just simply by clicking on a point and dragging into the inside, it creates an angle marker. And just like the hash marks, I can change these so that they're double or triple or quadruple or back to 1. So I'm going to talk about one more thing about this isosceles triangle, which is the difference I'm going to take the circle, and I kind of want to get rid of it, but if I hit delete, everything disappears. And the reason, so let me undo that. I'm going to go ahead, you can use Edit Undo, or you can use Control Z. And the reason why that happens is that this point is defined to be on the circle. And as soon as you get rid of the circle, then point B ceases to exist. So rather than deleting the circle, what I want to do is hide the circle. So the circle's still there, and this point is still traveling around that hidden circle. But it's a big difference between deleting an object and hiding an object. So I wanted to know, are there any questions before I move on, Karen? Hello?
Sorry, I had muted myself. Yes, there's a couple. First one was, how did you make the parallel markers? So that basically just going back to the hash marks.
Yeah, so the hash marks, you can use, you can right-click on them, or on a Mac, you would use Control, click, and then you can change them to either open arrow, hollow arrow, solid arrow, or crossbar. Right now, if I'm crossbar, if I did open arrow, it would go back to the parallel marking.
Okay. And then there's the question, is this only available in Sketchpad 5? So
yes, Sketchpad, the polygon tool, the marker tool, and the information tool, which I haven't talked about yet, are features of Sketchpad 5 as well, and are not part of Sketchpad 4.
And then, okay, so a couple questions. So how did you measure the segments basically? How did you verify that the segments were the same length?
So you can select a segment and go to the measure menu and then measure length.
Okay. And there's a question, can you change the orientation of the triangle so that it's actually on its base?
You can. You just have to sort of work with it a little bit, because what's really driving this triangle is the circle behind it. But yeah, you can change the orientation so that it's the way that isosceles triangles are typically shown. But one of the nice things about Sketchpad is that we don't always show them the way they're typically shown.
And we don't want to, right?
Because this is still an isosceles triangle, even though it's not on its base.
Right. And then last thing, can you quickly show how you hid again? Because I think you used a shortcut. So how'd you hide that?
I'm going to, first of all, to unhide, I'm going to go back to display, and I can say show all hidden. And so now the circle is back. And to hide it, I select it, and I go to display, hide circle. So whatever object you have selected, you can then hide through the display menu.
And why would you choose hide over delete? Why not delete it?
Because when you delete it, the whole thing disappears. So if I select the circle and hit delete, the triangle goes away because point B, I'm using undo now, point B was defined to be on the circle. In fact, this is a good time to use the information tool. In fact, let me actually hide the circle for a second and say, okay, this information tool allows me to click on objects and it'll tell me how they're defined. And right now it says point B is a point on circle AC. Now notice that when I hover over circle AC in this dialog balloon, the circle is shown again, but it's actually hidden. If I want to unhide it, I can actually click on it in the dialog box, and now circle AC comes up, and you'll see there's this little checkbox that tells me that it's hidden. I can uncheck it, and now the circle is unhidden. That becomes a lot more useful when you have a very complicated sketch with all kinds of stuff that's hidden behind it. Right now we only have one thing hidden. So I'm going to move on, okay?
Okay,
to the next
move
part.
on.
So one thing that's really great about using Sketchpad for looking at properties of shapes is that when you construct a shape using a different property, the way it behaves when you start moving it is different. So all four of these triangles were constructed to be isosceles triangles, but they were constructed differently. So I'm going to drag let me actually show the properties that I used first. All right, so One of these triangles was constructed so that it always has two congruent sides. Another one was constructed so that the base angles are always congruent. A third one was constructed so that using a line of reflectional symmetry. And the fourth one was constructed by placing the vertex angle on the perpendicular bisector of the base. So 4 different properties of isosceles triangles that I used to construct these 4 triangles. So I'm going to start dragging points. And I just want you to observe how these triangles behave. So both of these points seem to be doing very similar things to this triangle. And if I drag this point, it seems to be moving along a line. So that gives a lot of clues as to how it was constructed. Let's take a look at the second triangle here. Well, this behavior seems a lot like the one we just did a minute ago. You have this point moving around in a circle, so I'm thinking that this point's on a circle. And this might be the one I just did, using a circle to get 2 congruent sides. So this one has some extreme behaviors. Sorry about that. When I drag the vertex angle, nothing changes. So this point seems to be dependent on everything else, while these 2 points seem to do kind of similar things. And then finally, this blue one, it's got a very unique behavior that's different from the other ones. It has sort of this bouncing back and forth behavior when I drag these points. They both kind of do the same thing. And then this one, well, it kind of moves things around. All right. So before I answer this question, I want to give you guys a chance to take a stab at one of them. And so I'm going to ask another poll question. Before I show the poll question, because you won't be able to see the sketch once the poll is up, we're going to be talking about this blue triangle here. And what I want you to answer is, which of these 4 properties did I use to construct the blue triangle? Is it okay? So here's the poll.
And Andres, oh, sorry.
Yes?
I was just going to say, at some point when you get everybody back, can you show them how you colored the triangles different?
Sure. Great, we got about 2/3 of you voting already. I'm going to give you another 5 seconds or so. All right, last chance to vote. Looks like got over to the 80% mark. All right, let's close the poll. All right, so an isosceles triangle has one line of reflectional symmetry, over 60%, and then a pretty even split between the other 3. So those of you that the majority is correct. This was, and one of the reasons why you might notice the reflectional symmetry is because of this behavior where things are going back and forth. So I'm going to, the quick question that came up about changing the color, you can select a polygon, or for that matter, any object. You can also change the color of points and lines and anything you want to change the color of. But I'm going to change the color of this triangle by selecting it and going to Display, Color, and then either using one of the given colors here, or you can also go play with the other colors. All right,
Thank you.
So let's take a look here at what I'm going to go ahead and show all hidden so that we can see how these things were constructed. So this one here, you remember this one from a minute ago? This is the one I started off the webinar with, just constructing a triangle with two radii of a circle. So this one would be A, because it's been constructed so that these two sides will always be congruent. The green one, it has this line of symmetry, but this one was actually constructed, and now I'm going to go ahead and use the information tool to give me some information about some of these points. So it tells me that point 7 is a point on perpendicular line 5. Well, let's take a look at perpendicular line 5. Line 5 is perpendicular to segment 4, which we can see up here. This is segment 4, passing through midpoint 6. So this one was constructed, if we're sort of working backwards here, but what was originally done was a midpoint was constructed on the base, and then a perpendicular was constructed through that midpoint, and then a point was placed on that perpendicular bisector. So the green triangle here is the one where the vertex angle lies on the perpendicular bisector of the base. And then the one that I asked you about, the blue one, there were 2 points that define this dashed line, and that's the line of symmetry. One of the points was hidden. The other point is the vertex angle. And then there was just, again, if we use the information tool, we can see that one of these 2 points is an independent object, and the other one of these 2 points is a reflection of that first point across the mirror line. So whenever I drag this point to the other side, it just always is a reflection across that line of symmetry. I don't want to go into too much detail about this last one because it's a little complicated, probably a little more complicated than I want to get into for a session that's for people that are just learning how to use Sketchpad. But I did take this angle and measure it and then multiply it by -1 so that it became, converts clockwise to counterclockwise, and then use that to transform a point, and that's how I got to make sure that the 2 base angles would always be the same. All right, the real reason I wanted to do this is not so much to get at the answers, but it's more about the process and thinking about how engaging it is to look at these triangles and to try to investigate them, decipher them. It's looking for clues about how they were constructed, which really I think is a great way to engage students in deeply thinking about what these things mean. What does it mean to be a line of symmetry? What does it mean to have 2 congruent sides and so forth? This might be a good time. I'll take any, if there's any questions, I'll answer them right now. Otherwise, I'm going to go on to constructing a right triangle, and then we're going to move into quadrilaterals.
Now go ahead, because I think most of the questions we've answered and you've shown. Okay. So it's going great.
Great, thank you. So far these, so far we've been using the Sketchpad's tools to make constructions, but there are also some commands that you need to use sometimes out of the construct menu. And for example, to construct a right triangle, I need to have a right angle. And to get a right angle, I need to get a perpendicular line. Now, I'm going to construct this perpendicular line, but most people, when they first start using Sketchpad, find that they'll try to construct a perpendicular line, and this will be grayed out. Let me show you what that looks like. So you might say, okay, well, I want a perpendicular line through this point, and you go to construct, and perpendicular line is not a choice right now. And that's because in Sketchpad you need to give it 2 pieces of information. It needs to know which point to go through, but it also needs to know which line to be perpendicular to. So I need to select both the point and the line, and now I'll have the option of choosing perpendicular or parallel line. I want perpendicular right now. So that I've told Sketchpad I want this line to go through this point, and I want it to be perpendicular to this segment. And now no matter how I drag this original segment, you'll notice the perpendicular line keeps at a 90-degree angle. That's pretty much the essence of constructing the right triangle. After that, we just need an additional point on this line. And then I'll go ahead and construct a triangle. Oops, got the wrong tool. All right, so I just finished that, and I kind of used a shortcut that you probably couldn't tell what I did. So let me show you what I was doing. Let me unconstruct that. You can click back on your original point to complete the polygon, or you can double-click on your last point. So when I got to this point, I'm like, okay, I'm done. I double-clicked, and then it finished. And it's Sketchpad sort of randomly chooses colors for you. I'm going to change this color so that we can see better, because I want to do one more thing, which is add an angle marker. And notice that when you add an angle marker to a right angle in Sketchpad, it does square it off. Okay, so this point I can go wherever I want, and these 2 points will change the orientation and size of the triangle, but it will always be a right triangle. Okay. In Sketchpad, we use this thing called a drag test. And a drag test simply means to take all of the corners of the shapes that you see and drag them to reveal information about the shapes and how they were constructed. So here's an activity where we have 3 shapes that look like squares. But only one of these is actually constructed to be a square, and the other 2 are just pretending to be squares. So I'm going to start dragging some of the vertices to try to figure out which one's which. All right, well, so far that looks like it's a square. But now you can already tell that this is not a square. I'm going to go ahead and drag the other points and see what they do. So even though this shape's not a square, I can tell that it is a special quadrilateral. The opposite sides are always parallel, no matter which points I drag. So it looks like this is probably a parallelogram. All right, we'll look at the orange shape here. Right away on my first point here, I can already tell that this is not a square, because it does not retain 4 equal sides. But it looks also like a special shape. And then finally, the yellow one, I'm going to drag P, O. Neither of those do anything. When I drag M, it changes the orientation and the size, and so does N. But no matter what, I always have 4 congruent angles and 4 congruent sides. So yellow is constructed to be a square. And so right now, take another quick poll question. This orange shape, what kind of shape is it?
Does it appear to be anyway?
What type of shape does it appear to be? All right, great. Got over half of you already. There looks to be like a clear trend here.
I was going to say, look how smart everybody is.
Well, all right, great. So I'm going to close the poll here. And looks like the vast majority of you thought it was a rectangle. And then a small number of you said it was not enough information. All right, so I kind of set you guys up for this one because those of you that said not enough information, you're correct. Because when I dragged the first 3 points...
Hide your show because I can't see your screen.
Thanks.
There we go.
So when I showed you this one, I purposely only dragged 3 of the points. I did not drag point G. And when you drag point G, you'll be able to tell that this is actually a trapezoid. But so you need to drag all of the vertices before you have enough information to know what kind of a shape it is. All right. So let's construct some quadrilaterals. I'm going to start with, is there questions?
No, I just wanted to, just thinking of yesterday, the questions that came up. Can you go back to the sketch before? Can you just, we're assuming that these are squares and parallelograms, but can you just talk briefly about what you could then have students do to verify? Just real quick.
Well, the same things we talked about in the first page. You could go through and measure lengths. So in this case, you kind of can tell that the opposite sides have the same length. You could, I'm going to mark the angles, so I'm going to make these two single marks, and then this one I'm going to make a double, and this one I'm going to make a double. Oops, I made it too many. And I'm going to go ahead and measure all four of these angles. I can select them all and measure the angles. You could also do things like measure the slopes of the sides if you wanted to verify that they were parallel. So I'm going to select these two sides of the parallelogram and measure the slopes. Sketchpad creates a Cartesian graph, which I'll go ahead and hide. I'm just using the shortcut. I'm also going to hide the grid. But you can tell that the slopes remain the same to each other even as they change.
Cool.
So you can do, it all depends. There's a lot of power in just dragging points and seeing things that change and seeing things that don't change that are pretty compelling visually and for young learners. The measurement is a great technique for confirming the things that the patterns they're noticing. But then, as the kids get older too, this is just a jumping off point for starting to prove why some of these properties exist.
Correct. Thank you, Andres.
So I'm going to start with two fundamental quadrilaterals. I'm going to start with a parallelogram and a trapezoid. And with the parallelogram, I just created two segments, and maybe I should also make the point for those of you that are new to Sketchpad that when I construct the second segment, notice how that point gets highlighted before I click on it, and so that tells me that this new segment is going to share that endpoint. And this is half of a parallelogram so far. To construct the other half, I'm going to need a side that's parallel up here, that's parallel to the bottom, and then I'll need another side over here that's parallel to this sort of left side. All right, just like before, if I just select this point and I go to the construct menu, I can't do anything yet because I need more information. If I want to make a parallel line through this point, I also have to tell Sketchpad what to make it parallel to. So I'm going to select this side, this segment, and now I can construct a parallel line. So you can see that as I change the bottom, so to speak, of this parallelogram, the top adjusts. And then I can do exactly the same thing to construct this other side over here. I want another side that's going to go through this point that's parallel to this side. And you can already see the parallelogram. I'm going to go ahead and put a point at the intersection here. You'll notice that when I'm not at the right place, only one of the two lines will be highlighted. I want both lines to be highlighted. And so now it's constructing that point at the intersection. And now I'm going to go ahead and construct a parallelogram. I'm going to double click. And notice that Sketchpad automatically changes those two lines that were parallel to the opposite sides into dashed lines. That's also a feature of Sketchpad 5. It does some of that auto formatting for you. But I'm going to go ahead and hide these. And I just use the shortcut. I should probably show that. Just hide the parallel lines. And now you can see that this thing is a parallelogram. And another thing you can do in Sketchpad is now that I've created this parallelogram, I can save this and create my own tool out of it. So what I'm going to do is select the whole thing and go over here to this Custom Tools menu. It's the last thing on the menu, on the toolbar here. And the first thing I can choose there is Create New Tool. So I'm going to create a new tool, and I'm going to call it My Parallelogram. And now I can choose my new tool. I can go and choose my parallelogram tool, and if I click once, click twice, and click 3 times, it creates another parallelogram. So it's following the exact same series of steps that I used to create this parallelogram. Remember that when I started, I had to actually create 3 points because this point and this point and this point were all just free points in the plane. It could be wherever they want it to be. And then, so that's the given of this construction. So when I use my tool, it requires me to click 3 times because it needs 3 givens. It needs 3 points, and then it figures out where to put the 4th one so that it's a parallelogram. All right. I'm going to move on to the trapezoid, which starts off almost exactly the same. So I have these 2 sides, and I'm going to start it off exactly the same as the parallelogram because I still want a parallel side, say, to this base through this point. But the difference is that I don't need a second parallel side anymore. In fact, my last point can really be anywhere on this line. So I'm just going to put a point anywhere on this line. And I'm going to go ahead and construct a polygon. So this one has 1 pair of parallel sides. The other 2 sides are not parallel. As you move on into Sketchpad, you can get more sophisticated because the way I set this one up right now, this point can be anywhere on this line. So I could actually drag it over here, and then it doesn't look like the kind of shape that we consider to be a trapezoid anymore. It's a cross quadrilateral. So, I'm going to do one little trick that'll at least make it work for now, at least for this one. I'm going to go ahead and delete this point, and you'll see that the trapezoid's going to go away because I'm deleting something that it depends on. But I'm going to do a little trick here and make a ray that starts from this point and goes to one side. And then I'm going to construct this other point to be on the ray rather than on the line. In fact, I'm going to go ahead and hide this line. And now construct my trapezoid between those points. And you'll see now this prevents it from, it can still degenerate into a triangle, but it can't become a cross quadrilateral anymore. Go ahead and hide this. And I'm going to do the same thing. I'm going to go ahead and call this...
Andres, can you go a little slower with the tool creation because there's a lot of questions about that. So can you kind of go a little slower? Okay.
So the tool creation process is, okay, I've created my trapezoid, and I want to make it into a tool. It's actually much simpler than it seems. All you do is select the object you've created, go to the custom tool icon, and select Create New Tool, and then give it a name. And then you can use the tool by going back to that icon, and you'll see now that there's a couple of tools I have access to. I have my parallelogram, so I can choose my parallelogram and construct a parallelogram, or I can choose my trapezoid and construct a trapezoid. Although this one still has issues because it can still become a cross quadrilateral as a custom tool. So that gets more complicated than I want to get into, but it does.
Can you just go over how do they get a tool folder to put their stuff in once they make?
All right.
Get your stuff on your.
So let me point out a different resource real quick. The reference center that comes with Sketchpad is a great resource for more technical questions like this. I'll go over it briefly, but you can have a tool folder anywhere. You designate which folder you want to make a tool folder. In fact, you have this command here where you can choose your tool folder, and then you can either create a new folder anywhere on your computer or your desktop, wherever you want to do it. I have mine in my documents, and then inside of my documents I have a folder that I called tool folder because I didn't feel like being original. and that's where I have my tools. But some people have different tool folders for different sets of tools, and then you can always just go and select whichever folder you want to have access to at that moment. Anyway, for more resource,
can I just clarify? And so once they have something in a tool folder, then that's available every time they have Sketchpad open, right?
Exactly. Any sketch that you save into your tool folder, and any custom tools that are part of that sketch will be available to you whenever you're using Sketchpad, as long as that sketch is saved inside your tool folder. Did that answer the question?
I think that answered the question.
All right. So I've constructed 2 quadrilaterals. I'm going to construct one more. I'm going to let you guys choose which one to do next.
Wow, that one always seems to win.
All right, got over half of you. We got a clear trend developing here.
Very much so.
All right, give you 5 more seconds, then I'm going to close the poll. Great. All right, so almost 3/4 of you wanted the rhombus, so I'll do the rhombus. All right, so I'm going to start off, well, a rhombus has 4 congruent sides. So the first thing I'm thinking already is to use a circle. In a lot of ways, this starts off similar to the isosceles triangle. You can go back to the segment tool here. And then I'm going to go ahead, and just like with the isosceles triangle, I'm going to construct 2 radii of the circle. And so I know that these 2 segments are always going to be congruent. So that's sort of half the rhombus already. And now, just like with before with the equilateral triangles, there's a lot of different ways we could finish this off depending on which properties we want to use. For example, one thing we could do is construct this segment, and that's going to be a line of symmetry. So I can mark this segment using the transform menu as a mirror. And then I could take this half of the shape and reflect it across, and now I have a rhombus. But I'm going to do it a different way. But I did want to show that way as one option. There's a lot of different options at this point. So I'm going to go ahead and go back to where I was, and I'm going to stick with this idea of just using circles to get 2 segments of equal length, because I think it's a powerful one and one that kids really need to internalize, because that's what constructions are all about, right? I mean, when you're using a compass, you're always creating a circle, although you usually draw a little part of it. But the real important feature is that it's giving you segments of equal length. So I'm going to use another circle. The one I did so far had this as a center and this as a side. As a radius point. I'm going to go the other way around. So if I create a circle starting from here and ending back at the center of the original circle, I've created a circle of all the possible points where this 4th vertex might be. What do I mean by that? Let me draw a segment from this point to the circle. So these 3 segments right now are all congruent to each other. These 2 are congruent by the original circle, and now these 2 are congruent by the new circle. So I've got 3 congruent segments, but of course this is not a rhombus yet, because what I need to do is find the spot right here on the circle that's also going to give me a 4th side that's congruent. So to get that 4th point, I'm going to do yet again another circle, this time starting from this point as a center and going back to here. So now you can see that this point needs to come to right here so that it's at the intersection of those 2 circles. That way I'll have a rhombus. So I'm going to go ahead and construct a point at this intersection. You can see both circles are highlighted. I'm just going to jump to the polygon tool at this point and click on my 4 points. Oops, wrong tool. And there you have it. This is a rhombus. You can see that it has 4 equal sides. These last 2 sides are congruent by the last circle I just created. So these 3 circles are each pairing, giving you 2 pairs of sides next to each other that are congruent. You know, at this point we could hide these, and there's the rhombus. Okay. Any questions at this point? Because I think this would be a good time to jump into the topic of hierarchies. And
I think actually you should, because the only kind of question that came up actually relates to your next situation. So I think it'd be a great.
All right. So let me ask this question right now before we get into this last question, this last topic. I have one more poll question for you all. Is a parallelogram a trapezoid?
Wow.
All right. I see one person replying that it depends on the definition. And we got a good number of you voting on this one right now, so I'm going to go ahead and close the poll and we'll take a look at this. All right, so 60% said no, but 40% said yes. And I think anybody who said that it depends on the definition, that's really the best answer you could give. I wanted to force you to choose one way or the other. Most books in the United States define a trapezoid as having exactly 1 pair of parallel sides.
Hide your poll, Andres.
I'm not sure. Okay.
I'm just saying. There you go.
All right. So most books in the United States, in any case, define a trapezoid as having exact. Somebody's dog's barking.
That would be mine. I put him away, but he got out.
All right, so this is sort of the model that the typical Venn diagram model that you would follow if you define a trapezoid exclusively. And what I mean by that is you say a trapezoid has exactly 1 pair of parallel sides. So if it has more than 1 pair, it's no longer a trapezoid. Then it becomes a parallelogram, and these things are exclusive. And that's one way to define things. You could also define it differently. You could say that a trapezoid has at least 1 pair of parallel sides, in which case then the parallelogram is a subcategory of the trapezoid. And this is a model that's used in some other countries. We had a person yesterday from Croatia who said this is the model they use in Croatia. And you could argue either one. You could basically break it down and say, like, well, it depends on the definition. But I'm actually going to make the case that I don't think that makes sense to me. And the reason is this. I think everyone agrees on the fact that a rectangle is a special case of a parallelogram, and that a rhombus is a special case of a parallelogram, and that a square is the overlap of those two, that a square is a special case of a parallelogram that's both a rectangle and a rhombus. So to me, when I think of a Venn diagram and something is inside of a bigger category, it's a special case of that category. So let's go to this diagram, and I'm going to use my tools here. I'm going to construct a parallelogram. All right, so here's my parallelogram, and if I put it in the Venn diagram, this is where it belongs. But this is just a general parallelogram. And I could take this general parallelogram and I could manipulate it so that in this one special case, it becomes a rectangle. Or I could manipulate it so I get another special case. Got to figure out which point to drag. There we go. Where I have a rhombus. And I could manipulate it even more so that I get to that other special case where it's both a rhombus and a rectangle. And it becomes a square. All right. Now I'm going to take this trapezoid, except I don't think my trapezoid tool is going to do what I want it to do. Oh, there it did. Good. All right, so here's my trapezoid. And, you know, I'm thinking about this, and I'm saying, well, this is just a general trapezoid, so it belongs here. But I can take this trapezoid just like I took my parallelogram, and I can manipulate it so that it becomes a parallelogram. So in my mind, that sort of follows the same logic. If I can take this general trapezoid and make it into a parallelogram, then it's a special case rather than a completely different category. Anyway, I find that kind of interesting. And you know, what's really more interesting is that students can get involved in this debate, and they can take sides, they can argue it. You know, I've brought this issue up with my daughter in middle school, and she was happy to agree with me. But the point was that she thought about it, and she agreed with me because she decided she liked the logic I was presenting. So just thought I'd throw that out. You can also look at these things in terms of tree diagrams. This will be included in the materials that you're going to get if you want it from the zip file that you get from this webinar, so I'm not going to spend too much time on this, but you know, it's a very different tree diagram if you use inclusive definitions than if you use exclusive definitions. All right. So back to the first poll you took. Those are the 27% of you that said 5th grade. You were right. So here they are. Common Core standards for mathematics. If we have any people from out of the United States today,
hide your poll.
Thank you. So if we have anyone from outside the United States, the Common Core state standards are a set of standards that have been adopted by about 3/4 of the states in the United States. And you can see right here, this is 5th grade standard, classify two-dimensional figures into categories based on their properties, and specifically classify two-dimensional figures in a hierarchy based on properties. So I was I was surprised to see that. I was expecting to find these kinds of things at the middle school level. But they come very early, and in fact, I'm going to show you that this, you know, the Common Core follows these learning trajectories over a number of years. And so, for example, with this particular topic, if we look at the 3rd grade geometry standards, that in 3rd grade you already have understand that shapes in different categories, for example, rhombuses, rectangles, and others, may share attributes, and that the shared attributes can define a larger category. So you already see this beginning in 3rd grade. If we jump to 4th grade, classify two-dimensional figures based on the presence or absence of parallel or perpendicular lines, or the presence or absence of angles of a specified size, recognize right triangles as a category, and so on. We also have recognize a line of symmetry for two-dimensional figure. And then in 5th grade, you have classify two-dimensional figures in a hierarchy. Notice that they don't actually spell out what the hierarchy is, so the whole issue we were just talking about inclusive versus exclusive definitions, is not prescribed. And really the more important thing is to think about the properties and how you would arrange them into a hierarchy. But for students in grades 3, 4, and 5 to really have any access at this content, they're going to need to have hands-on experiences, whether it be with a compass and straight edge, or paper folding, or dynamic geometry, all of which are specifically described in the Common Core under the process standards. They're going to need a way to really get their hands on this kind of geometry in order to be able to do this pretty high-level stuff at a pretty young age. All right. Let's then just go into one last topic here, which is constructing polygons using rotation. This will help me get a little bit into some of the other transformational capabilities of Sketchpad. So I have 2 points here. This first point I'm going to mark as a center. So I'm going to go to transform and mark it as center. And now this second point is going to be one of my vertices on my polygon. And I'm going to rotate it, and I'm going to rotate it by if I had a poll question set up, I'd ask you, but since I'm going to make a pentagon, I'm just going to tell you that it's 72 degrees. And I can continue doing that a couple more times. And that gives me a regular pentagon. Oops, look at that, I blew it. So let me undo that, undo that. I had a hidden point I didn't see originally, okay. All right, so there we have a regular pentagon, and there's different ways you can introduce this activity, and the materials that come with this webinar, you can take a look at the sketch. In this case, I just said 72 degrees, but you can also have students explore with different angles of rotation and kind of discover eventually the relationship that you have to divide 360 by the number of rotations that you're going to make, because really what you're doing is you're looking at the exterior angles. But you can do any regular polygon this way, and I'm just going to finish off with this fun little model that we have where this gets more into area. But we have this model where you can look at regular polygons and change the number of sides and start looking at how you would calculate the area for each one of these by breaking it down into isosceles triangles. And so there's a series of calculations that the students can do here and kind of start to see a pattern. And then you can take this pattern, and when you take it to the extreme, you can see that as you reach the limit of n sides, as the sides get smaller and smaller and smaller, you're approaching the area of a circle, which is you can see that the area of the polygon and the area of the circle get closer and closer as the number of sides increase. Anyway, that was a little off topic. I just wanted to share another model, and I'll take any other questions that anybody might have at this point.
There's one question back to your construct polygons, regular polygons. So I guess the one after the tree diagram. No. Back.
Oh, the regular polygon.
Yeah, that one. They wanted to know how you got your initial angle.
Well, that's because I knew I got my initial angle by taking 360 and dividing it by 5 in my head. But the way I actually made it was to I had 2 points. Whoops. I marked one as the center, and this is just going to be one of my vertices, and I need 5 of these, or let's do a different one. Let's say I was going to do a 6-sided figure, then I would rotate it by 60 degrees, and then repeat that process.
So for the students to figure out the angle to rotate, they would have to know 360. Right.
It depends on what level they're at and what prior experience they have. I mean, I think this is actually a good one where I would give the students the direction of trying out different angles and repeating the process until they ended up back where they started, and then have them figure out what the relationship is between the numbers of sides and the angle of rotation, if that makes sense.
That makes sense. There is another question that might be a more complicated answer, but so it's about how did you create the slider for the number of sides? I don't know if we want to get into that now.
Yeah. So this is a much more complicated topic, and way beyond the purview of a beginning seminar.
Let me jump in for a second and just suggest that if you look at if you go to the reference center from the help menu and go to the index and select slider, there's an entire topic on how to create a slider.
L. Keep going.
I can't spell.
Keep going.
There we go.
There you
All right. So, and while we're there, I also want to mention that one of the great things about Sketchpad 5, for those of you who have not seen Sketchpad 5, is Sketchpad 5 comes with a learning center. And this is an incredible set of resources, from videos to tutorials to get started. I'm not going to show everything, but there's a whole set of tutorials. Each of these tutorials are step-by-step, and they also have embedded videos themselves that guide you through it. And then there is a whole teaching with Sketchpad that talks about how to use it at different levels, a whole set of sample activities for different grades. There's 40-something activities that you can just download with student worksheets and teacher notes and sketches. So this is a great place to start. And then from there, another thing we also offer at Key Curriculum Press are 6-week online courses. And so these courses are moderated and allow you to really get involved in Sketchpad, working through activities that you would then end up using with your students. So just wanted to make a quick plug for those two things.
And let me just, it's time technically for us to end the webinar, but though we're happy to stay on and answer questions. I did want to answer a couple that have just come up that pertain to everyone. First, yes, you can get a copy of the files that Andres has used. When we post the recording, we also post a zip file of the documents that are used. Sorry, my dog is barking again. And so that will be posted on our website, keypress.com/webinars. Just look for the archive, and you'll get an email with that link as well. It takes me about 2 days to get that up there, so eventually both the files and the video will be up as well. And then there was a question about if you have Sketchpad 4 and you want to get an upgrade. You can upgrade to Sketchpad 5, and it's, I don't know the price. I think it's like $30 to upgrade if you have a single user, and it's less if you are going to get more than one. That's all on our website again, keypress.com Sketchpad. So yes, that is available. And I think that is it. Oh, there is a question about when we're going to start offering advanced Sketchpad courses. We are going to hopefully start doing those soon, definitely in the next year, starting in 2011. We might have some in December, since we don't have anything else scheduled. So just stay tuned to our website, and we will post any upcoming webinars. But yes, we are going to start having some advanced webinars for Sketchpad. And I'm done. So Andres, are you still there?
I'm still here, and thank you all for coming today.
So thank you. If you want to stay on and ask questions, we'll stay on for a couple more minutes. And if not, have a good evening. Thank you for joining us. Thank you, Andres, for your great presentation. Thank you, Scott, for your busy typing there in the background. Appreciate all your answers to the questions. And thank everyone for coming.